Hello everyone. So the next type of problems by using Carney's method is frames. So we have already dealt with analysis of beams, that is fixed beam, simply support beam, and overhanging beam. So the next type is analysis of the frame without sway. Okay, and using by using Carney's method. Okay, now see here. So if there is no sway happening in the frame, then the analysis procedure is same like before. Now again, in the given problem, they will not mention whether it is sway or non-sway. So you have to analyze and check out whether it is sway or non-sway. Now just by seeing the problem, you can conclude. Now see here, this is already we have solved this problem previously by different method, that is I guess by slope deflection method. The same problem is solved by Carney's method. Now you can see here, analyze the given rigid frame by Carney's method. Okay, now see here, A, B, so it is A, B, B, C and uh, C, D. So A and A is fixed at end A is fixed, B, C and end D is overhang, and BF and CE are the columns which are fixed at F and E. Okay, so now you can see here, just by seeing the frame you can make out whether it is a sway or non-sway. Now even if the beam wants, if the complete frame wants to sway also, it doesn't sway because this is a fixed support here, so that will restrain the sway movement and will stop it from swaying either to the left or to the right. Okay, so now this is a non-sway frame. Okay, so again the procedure is same. First we'll find the fixed end moments, then we'll find the rotation factor, and then followed by rotation factor, followed by the rotation contribution. You can see here this rotation contribution, and then the final moments. Okay, okay. So first the fixed end moments. First find the fixed end moments as usual. Okay, so fixed end moments, you can see here, notice this thing here. Uh, just a moment. First fixed end moments, that is AB, BA, find it as usual. MFAB is again it is eccentric loading here, eccentric loading. So because it is eccentric, so it is minus WAB square by L square. Okay, then FBA is plus WAB square by L square. Next, BC. So BC is UDL, so minus WL square by 12. CB is plus WL square by 12. Then CD will not exist. Okay, so bending moment in CD, okay, is minus 30 into 2, that is 60. Bending moment, fixed end moment at D is 0 because it's a simply support. Then in BF and CE, these are the columns. Now in the columns there are no load acting anywhere in the column, so that's why MFBF, MFFB, MFCE, MFEC, they all are columns without loadings. Now because they are without loadings, the moment is 0. Okay, next, so once you find out this, next is the rotation factor. So rotation factor is nothing but again same thing, you have to use the formula minus 1 by 2 k by summation k. So this is the rotation factor. So joint B and C, so it is same like beams itself. So what we're doing here is B and C, we are drawing two columns, these are the two joints which connect three members here: B, BA, BF, BC, C, CB, CE, CD. So like this they connect all three members. So we will draw two, we'll find the stiffness, okay, rotation factor for joint B and joint C. Okay, all right. So first joint B, so first BA, BF, BC. So go in order only: BA, BF, BC. Then here also CB, CE, CD. Okay, first BA. Now see here, BA, BF, BC, all are fixed supports, so it is 4 EI by L. Similarly, Come to this joint now. CB, CE, CD. Okay. So first BA, 4A bell, 4A bell, 4A bell. All three are fixed. Similarly, CB, CD. But CD, same thing. See, CB, 4A bell, CE, 4A bell. Whereas CD, now this is like a overhang. Because it is a overhang, no movement occur here. So here in this portion it is 0. Okay. So it is 0. Then as usual, substitute all the values here. I, 2i, just check the values 2i and I where it exists. Then as usual, go on filling the substitute and simplify. Okay. So you get k, summation k. So this is rotation factor. Find for all three members. So let it be in a cycle only. So BA, BF, BC. Okay. Then similarly, find out these. Okay. Once you find the rotation factor, now this is important. Now how to solve this is important. Now you have to draw this as it looks like the frame only. So A, highlight this B and C, then keep this joint D overhang, then show here extra. In this there is an additional step you have to do. That is, you have to draw additional column here, 1 and 2 as such. Okay. Then as usual, see here, write the fixed end moments. Okay. Now how to write this fixed end moments here? AB. At AB, this is the fixed end moment. You have already calculated here. Minus 4.44. Then BA 8.89. Then BC it is minus 64. CB it is plus 64. Then CD it is minus 60. And at D it is 0. Alright. Okay. Next. Mark this rotation factors. Okay. This rotation factor here. So first is minus 0.143. It is 0.143, 0.143. First, you have to, this is connecting A, BA, you have to write it here. Next, BE, wherever it connects, so B and E. So it connects here, so you have to write in lower portion of the square. Then BC, it is connecting here, so it is right portion of B. Write it here. Similarly, CB and CD. So CB, it is minus 0.25. CD, CE, it is again minus 0.25. And here it is 0. So you have to write like this. Wherever it connects, in that particular portion, you have to write the fixed end moments, rotation factors and fixed end moments. Okay, now next, carrying out this iteration is important. Okay, now check this out. So it is first 8.89 minus 64 is minus 55.11. Similarly, 64 minus 60 is plus 4. All right. Okay. Now next is you have to calculate the moment here. Okay. Now see here, 8.89 minus 64 is minus 55.11. Okay. So it is 8.89 minus 64 is minus 55.11. Okay. So now you have to carry out the first iteration. So now you have to write it like this only. Now see here, this is BA. Okay, whatever exists in BA, like this, write it in this portion, left side. So this is like the column. So whatever exists to the A side, so this is BA, write it to the left side, right? Next, BC. Okay, now see here, BC, you write it below this beam. All right. Next, BF, whatever exists here, BF, write it here. So it should be here. It is simple. What you have to do is writing this. Writing this is very important now. Okay. So BA, write it here. BF, write it here. BC, write it here. Okay. All right. Now see, minus 55.11, minus 55.11 into this portion first. Minus, so far end there is nothing here because this is the first step we are standing. So minus 55.11 into minus 0.143 is 7.88. Write it here. Next, minus 55.11 minus 0.143 is in the column section. So write it here. Next, minus 55.11 into minus 0.214. Okay. So it connects to the C, that is next beam. Okay. So that you write it here. Okay. Next, Similarly, come to the next column now. Okay, this portion is over. This is the first step you write. Next is come to this. So it is 4. Okay, this is the fixed end moment. Final. So 4, okay, plus the previously existing in the beam. Okay, so previously existing here is you have to take this. Okay, that is 7.88. Okay, 7.88 into, so this is the first one, this is 7.88 which connects here. Next is 4 plus 7.8 into 0. Minus 0.25. So whatever exists here, write it in this portion. Whatever answer you get it, you write it to the right side of this. Okay. Okay, next is again come back to this point now, 55.11. Okay, minus 55.11. Again solve for this, minus 55.11. Take the far end now, minus 55.11 minus 2.97 into come to this minus 0.143. Okay, it is 8.305. Write it here. Similarly, here also it is same. The rotation factor is same. You can write the same answer. Here what happens is minus 55.11 minus 2.97, because these are the two members connecting. So minus 2.97. Okay, minus 2.97 into 0.25. Write it here. Next, same answers would be same here because the rotation factors are same. Okay, next come to this portion. Okay, so minus 55.11. Okay, far end, again far end is minus 4.107 into 0. Minus 0.143 is this answer. Same here also same. Again minus 55.11 minus 4.107 into 0.214. Answer, write it here. Next, similarly, the same, carry out the same iteration. 4, again from the far end, minus 4, okay, uh, minus 4.4 plus 4. So this is plus 4, then plus 8.468 from the far end into minus 0.25. Okay, so write it here. Okay, so carry out this iterations like this only continuously. Go on checking the same thing. Whatever you find out here, from first simple thing is this portion, fixed end moments from this portion plus the far end. Okay, take first far end is this, take this and then multiply with rotation factor. Similarly, this fixed end moments, take the far end moments that is from this portion and multiply this rotation factor. So go on doing this iterations until there is no much difference in the previous step. See 7.66 is this is 4.76, this is 0.8.477. See here 77, so difference is not much. Similar here, it is same, here also it is same. So you should go on doing like this. Okay, go on doing like this, and then this is a point where you need to stop. Okay, so then you'll get BA, BF, BC, CB, CD values. Okay. So once you calculate these values, the main important thing here is how to write down these values are very important. Okay, you can see here. So this is 7 point. Okay, this fixed end moment. Okay, this is the fixed end moment here. For BA, write it in this portion, left side of BA, B. Okay, BC, write complete to the right side. Okay, whereas BF, write it just adjacent to that only. Similarly, at this point, CB, write it here only, near the column. Okay, CD, write it here. In case if there was CB here, extra additional column, then you have to add this. So right now it is simple. So later you need to sum up this properly here. Okay, So fine. Next is the final moments. The final moments are fixed end moments plus 2 times near end contribution plus far end contribution. So in this you cannot, again, because it's a column, you cannot draw the table here. So just put this formula. Then you can just write MFAB is equal to fixed end moment. Directly you can write fixed end moment we already calculated, plus with respect to AB there is no near end. Okay, there is no near end, but the with respect to AB far end is BA. So write down this. Next, similarly BA, MFBA. So it is MBA, MFBA plus 2 times near end. So with respect to BA, near end is, this is near only, 8.47 near end, plus far end, there is nothing in the far end, so it is 0. Okay, so like this, go on calculating. Okay, now for example, I'll tell you about this. Okay, BF, that is a column. So how to write down this is BF is a column. Okay, so here what you're supposed to write is, in BF, first fixed end moment of BF is 0 because there are no moments only, plus 2 times near end. Okay, 2 times near end. Again, BF, the near end is, we have calculated it, so it is 8.47. So there is a lot of difference between BF and FB. Okay, there's a lot of difference between BF and FB. So right now we are talking about, so this is BF, that means we're going on writing from B which ends at F. Okay, so BF is near end is 2.2 times 8.477. Okay, plus far end. So far end there is nothing here. FB is 0. Okay, now see here, BF is 8.477, but FB is 0. Okay, similarly here also CB is 4.1 minus 4.171, whereas EC is 0. Okay, so like this, go on adding. Only thing you should know is what is near end and far end. With respect to B, whatever connects B, that is BA, B F and BC, they're all near end. Here also CB, CD, they're all near ends. Rest all are far ends. Okay. Okay, this is how you calculate and write the pending moment. Okay. Here, as in, you don't get the check because there is one member which connecting B member connect three members in a joint. So here you not get the exact answers like equal and opposite. So you can just write this as usual. Okay, near end, far end. Only thing you should know what is near end and far end. All right. Okay, that's all for today. Thank you.